Hello, good morning, good afternoon, good evening. Welcome along to today's session. My name is Stu Pringle and I'm part of the team here at Empire Engineering, and I'm going to be your host for today's session. Today we are talking about the very hot topic of floating offshore wind, and I'd like to thank you all for coming along. I'm going to be joined today by two of my colleagues at Empire, Zigeng and Eric Paya. And just a quick word about us, Empire Engineering. We are an engineering consultancy supporting the offshore wind industry with advice, insight, and technical know-how. We're headquartered in Bristol in the UK. We have an office in London, and we can be deployed anywhere around the world. Before we begin, just a little bit of housekeeping from me, and then we'll go on and meet our speakers. This is our first ever crowdcast, so please bear with us. It's a little bit of a test. You'll see down the right-hand side that there's a chat forum. Don't be scared to say hello. I can see lots of you here already. We've now got 70 people live for our first session, which is pretty amazing. We'll be sharing our screens during the session. You don't need to do anything on your side. If you have a question, you can submit them at Ask a Question along the bottom. We're also going to be encouraging some audience participation today, and we've got a couple of polls lined up for you to take part in during the session. When I say poll, if you click poll at the bottom, you'll be able to take part and we can see all the answers. And finally, very, very important, if the quality of the audio, if anyone's struggling at all, if you look at the bottom right-hand side, there's a little cog sign. If you click that, the default is HD. If you go down to 360, the video quality will be lower, but the audio quality will be nice and clear. Okay, that's enough housekeeping and probably enough for me. Let's go on and meet our speakers. So I'm just going to say hello to Eric, and I'm just going to say hello to Aaron. There we go. Here we are. Oh, we've got an Eric. Have we got an Aaron? Where is Aaron going to? Bear with me 1 second. This is the joys of doing live sessions. Here he is. I found him. Here we go. Aaron, are you there?
Hello. Can you hear me?
We can hear you. We can't see you. So tell you what. Here we go.
Oh,
there we go, everyone.
Hi.
Excellent. Aaron, could you tell me a little bit about yourself?
Sure. Thanks, Stu. Hello, everyone. My name is Aaron Du. I'm head of the London office at Empire Engineering. So I'm an offshore structure engineer. In the last 10 years, I've been mainly focusing on the structure integrity management and advanced structure assessment of both fixed and floating assets. My first offshore floating wind experience was gained back to 2009. It was a R&D project for ETI, a feasibility study of a tension leg platform of floating wind foundations. I spent a lot of time on the finite element modeling and also stress analysis. Today, I'll be very pleased to join my colleague Eric to discuss floating wind. Eric is heading up our floating wind business. I'll hand over to him to introduce himself.
Thank you, Aaron. Hello, Eric. How are you doing today?
Hello, Stu. I'm fine. Thank you. And thank you, Aaron, for this transition. So my name is Eric Paya. I joined Empire Engineering in November 2017. I have 24 years of experience in the offshore industry, working for small consultancies, main EPC contractors, major oil and gas companies all around the world, from Japan to Africa to USA and Spain and the North Sea. And I spent the last 4 years in the offshore wind industry, specifically in the offshore wind industry. I've had experience in a floating project, starting in 2002, working for a company called SBM Offshore, known for the FPSO and mooring systems. So my first experience was offshore Nigeria for a project for Shell. The last experience in a floating project, in floating offshore wind, was for Kincardine project of the coast of Scotland. And today I'm very happy to meet you all and to discuss floating wind technology.
Brilliant. Thank you very much, Eric. Okay, I'm just very quickly going to show everyone the agenda. So we are going to talk about these things today. Introductions we've done, and then you can see there we're going to go through various aspects of floating offshore wind. Okay, so why don't we start with the absolute basics? Aaron, what do we mean by floating offshore wind?
Okay, so basically the floating offshore wind means the wind turbine is installed in the sea and supported by a floating structure. So floating wind structures are normally located further from shore in the deep water depths and to capture the strong and steady wind. So floating wind removes the limit of water depths, which the conventional fixed floating wind, fixed bottom wind has. So, however, the harsh sea environment for the floating wind, including the strong wind and strong wave, in conjunction with heavy wind turbine, will lead to the higher structural risk of the floating wind comparing to the fixed wind. So today, Eric and myself will discuss opportunities and challenges of the floating wind from its whole life cycle.
Perfect. Well, Aaron, thank you very much for that. Okay, so we've done the basics. Now we know what it is. Let's talk a little bit more in depth about where it can be suitable. And one of the topics that often comes up is the depth of the water. So question to you, what kind of range of depth of water does floating make sense? And I'll go to Eric with this one.
Hi, Stu. Thank you for the question. It's probably one of the most difficult questions today.
I thought I'd start with a good one.
Yeah. So yeah, it's a difficult question, but I try to answer. So actually, I believe that the water depths at which we see the transition from bottom fixed to floating wind depends on different factors. So there's not one answer for one solution. So the different factors could be, first of all, the environmental conditions, so the wave, the wind, the current, affecting obviously the floating structure. The second factor is the wind turbine itself. So the size and the weight of the wind turbine is going to carry, and the coupled dynamic effect between the floater and the turbine itself.
Okay.
The third factor, or third parameter, is the local, the regional or national harbor and the yard infrastructures that are available. For example, where and how we're going to build the floater, where and how we are going to to assemble the turbine on the floater. Another parameter is the TNI, transport and installation methodology, the availability of installation contractors, the vessels. And finally, from my point of view, last but not least, is the O&M strategy, how we are going to maintain the floater, how we're going to allow access to the floater and to the turbine, how we intend to change major components. So all this is taken into account to decide on the water depths. So to answer to your questions, and give a precise number is very difficult. Some studies recently give different results, but they converge more or less to one general view, one general opinion, is that fixed foundations become uneconomic in a range of water depths between 40 to 60 meters.
Right, okay. Very interesting. Aaron, have you got anything to add to Eric's points there?
Yes, I think, I agree with Eric. So the 60 meters water depth seems like a frontier between the fixed wind and the floating wind, and it is also widely accepted by the industry. But it's worth noting that 80% of the world wind resources are located in the water depths greater than 6 meters. So the development of the floating wind cannot be ignored. So in addition, from the technical perspective, technically, the floating wind can be installed as low as the 40-meter water depth. So between the 40 meters and 6-meter water depth range, as Eric just mentioned, the floating wind can be competitive under some circumstances. So for example, the hard rock seabed conditions is not very suitable for monopiles and jacket foundation piles. So the floating wind can be an option in that seabed condition.
Okay, Aaron, thank you for that. So look, it's really clear that there's a lot of potential and opportunity for this technology. Is it still at the prototype stage? Eric?
Thank you, Stu. I don't think it is at prototype stage. Well, I mean, the floating wind technology as a whole is not a prototype stage. We heard 2 days ago, and the conference organized by the Norwegian offshore wind cluster, we heard from one utility company that it's actually going out of the prototype stage and entering the cost reduction stage. I would even say commercialization stage. There are obviously some prototypes installed currently in the offshore in the water, in USA, in Japan, in Spain, and there will be even more prototypes to be installed in the coming years. But some technologies have already passed the prototype stage and are ready for commercial, maybe pre-commercial project, such as Equinor's Highwind spar, Principal Power semi-sub, or Ideal barge concept. And other floater suppliers or other floating technologies are doing huge efforts, tremendous efforts, to get ready for this commercial scale.
Okay.
So for me, I believe that it's my opinion that technology as a whole, again, is ready. Developers and utilities are definitely ready and actually fighting to be the world leader in this area. The supply chain is ramping up and is adapting as well to this new market. And the investors as well are responding present to the call of the floating wind.
Okay, interesting. We've had a question about costs, fixed versus floating, which I do want to come to today. So we will get into that. But it was interesting what you just said there about the different types of design. Aaron, could you just give us a little bit more detail about that, please?
Sure. So the concept of floating wind structures actually is originated from the oil and gas industry. There are 4 typical foundation types: barge, semi-submersible, tension leg platform, and a spar. So each prototype has its own pros and cons. For example, the semi-sub is suitable for a wide range of the water depths comparing to spar, but its structure size is normally larger than the tension leg. For tension leg platform, it has very good stability, but it has higher the cost of construction and anchoring system. So I think, Eric, would you like to add a bit more on this?
Yes, Aaron, absolutely. So on those 4 different concepts, I would like just to highlight something. So at the moment, the spar concept with Equinor Highwind has the highest number of floaters installed in the water. I think it's about 6. I think it's 6. While the semi-submersible concept is right behind it. Currently, I see you are putting that on the screen. So really, the difference in terms of number of floaters installed is not that much. 1 digit or 2 digit doesn't make the difference at this stage. So we don't know how long the ranking will stay like this. We don't know how long one floating technology will remain the leader in this market, because the competition is really harsh between the floater suppliers.
Okay.
One thing to say, Stu, if I
Yeah.
No, just to say that, so we are aware that Scotland has issued the ScotWind lease, and it will be very interesting to see the result of the ScotWind lease and see which concept or which technology comes first of this very exciting race.
Okay, well, look, we have got 99 people live just now. Why don't we ask the audience? What they think? So look, I've got a poll here, which I'm going to make visible, which has those 4 options. So if everyone at the bottom of their screen clicks polls, they should see it pop up. And this poll is called the Great Fow Showdown. Which design will be dominant? So come on, there's 100 people now online. We can get a really good view here. Who thinks? Oh, here we go. We got some votes coming in. Right, semi-submersible is in the lead. Oh, barge has got 1 vote. Spar and tension leg, no votes. Oh, it looks like a bit of a whitewash for semis. Oh, hang on. Here we go. So we've had about 40 votes come in. I'll just keep it running for a little bit longer. So it looks like semi-submersible is going to be the popular choice today. Votes are still coming in. Aaron, Eric, can you see that?
Yeah. Oh,
I haven't seen the results yet.
Okay. So I think the it's on the screen. Hang on. Right. I shall stop that. Right. So it is running at can you see that now? We got semi-submersible nearly 70%, barge 8%, spar 14%, tension leg nearly 8%. So it looks like semi-sub is the clear winner. So there you go. There's our poll today. Thank you very much, everyone, for taking part. Isn't that an interesting result?
Yeah, it is. I think in line with my thinking as well.
Interesting. Right. Well, let me just drop that away. So that should be hidden now, and it's back to the three of us. Okay. We've getting some questions coming in, but one of the early questions was about costs. So why don't we get into that a little bit more? Floating winds, cutting edge technology, a lot going on. Doesn't necessarily mean that it's more expensive. And I like giving, I'll give the first difficult question to Eric. So why don't I give this one to Aaron?
All right. So for cost is always the most important topic in the floating wind field. So for today, I think the short answer is yes, the floating wind is much more expensive than the fixed wind. So the current cost of floating wind can be 2 to 3 times higher. But however, the floating wind has significant opportunities of cost reduction in a number of areas, especially in the next 10 years. So for example, the design optimization, assembly, installation, maintenance, and decommissioning. So based on many industry forecasts, so the cost of floating wind could drop around 70% by 2030. So which will make the floating wind is financially comparative to the bottom fixed wind.
Okay, interesting stuff. So at the moment, the answer is yes, but you think that's going to change?
Yes.
Okay, all right, brilliant. What about design challenges? Why don't we get into that side of things? What design challenges are specific to floating wind? As a developer, what should people be looking out for? Aaron, I know we chatted about this the other day. What's your views on that one?
Thanks, Stu. I think it's a good question. For biggest design challenge, I think, would be how to maintain the structural stability of the floating wind. At the same time, to reduce the structure size and the steel weight. So in order to reduce the capex. So, floating wind is the top-heavy structure, which is under the complicated dynamic loads. Assessing the structural stability and integrity of floating wind structure is essential in the design process. So floating structures need to be properly analyzed for the integrated loads, considering the coupled effects of the aerodynamic loads and hydrodynamic loads. The interactions between the floating structure and the mooring line system need to be considered as well. So this will require the close collaboration between the wind turbine OEMs and the floating design prototype designers in order to accelerate the process of design optimization process.
Brilliant. Thanks, Aaron. I think you've picked up on a couple of the questions that were being asked by some of the audience as well. So that's really useful. Eric, have you got anything to add on that, specifically talking about the design phase?
Yes, Stu, I would like to add a few things, just following up on explanation. As we said at the beginning, so the choice of the floating solution depends on other parameters, which are fabrication and yard capabilities, the TNI methodology, the O&M strategy. So in the design phase, the wind farm developer and the floater designer should take into account all the different parameters coming from those disciplines. So let me give you a few examples. For example, in the fabrication sequence, commercial projects with large number of floaters, 50, 100 or more, will mean industrialization. serial fabrication, which itself will probably induce modular design and modular fabrication. So we can imagine blocks, part of the floater, already pre-designed, maybe pre-certified, and even the fabrication assembly, fabrication process already predefined. So it's very important that the designer of the floater takes all the fabrication constraints into consideration from the beginning. We can even imagine the fabrication contractor or the yard having a large influence into the design from the beginning. Another example is the yard characteristics. Sorry, typically the dry dock dimensions. How deep is a dry dock? I have been involved myself on a project where we modified the center of the buoyancy of the floater just to make sure it could go out of the dry dock. So you see how the interaction between the construction phase and the design itself is really tight. As a matter of fact, in the same webinar 2 days ago, organized by the Norwegian Wind Cluster, I liked the statement from one speaker who said, think about how you're going to build the floater first and then design around it. So of course, it's a point of view. Floater designer may have a different point of view, but it's just to show how important it is. I can give a third and final example as well. The parameters that impact the design is, as we said, the TNI methodology, how we are going to tow to site. So tow to site, and I see a question, tow back from site to shore. So this has an impact on the floater design. How we are going to pull the mooring lines, how we are going to connect the mooring lines. Eventually, a requirement for quick disconnection. So all the things put together will have an impact on the design of the floater.
Okay, that's really good insights. Thank you, Eric. So we talked there a little bit about the design phase. What if we move on to sort of the assembly and installation? Again, what from a floating point of view, what's really important to be aware of? Now, who should I give this one to? Oh, Eric's stepping up. There he is. Okay, Eric, go for it.
Well, just to say, I mean, we've just discussed that the input of the TNI or the transport and installation is really important. So the relation between the design, the assembly of the turbine, the transport or the towing and the installation, everything has an impact on the design. It is already the case for fixed offshore wind foundations, but it's even more relevant, more true for floating foundations. What is particular to floating foundations is that the floating structures, the floaters, do not require heavy lift vessels or heavy marine sprays. So that's really one of the big advantages of the floating technology. There's a very good example we've seen in the media recently, a couple of weeks ago, even last week, some good videos and photos of the WindFloat Atlantic project, which has been installed off the coast of Portugal, and we see the floater just being towed to site with the tug. So it's really the main advantage of the floating technology. Brilliant. We will also see different installation contractors, new offshore contractors. They will be different from the current TNI contractors leading the fixed foundation market. I'm not going to give names here, but we will see newcomers, people who are already in the offshore market in general, already providing marine services, but with smaller fleets, smaller vessels, and they will compete with the bigger players. So I think this competition will be healthy because it will reduce the cost down.
Excellent.
Thank you.
That was a lot. That was a lot. Aaron, anything else we should be aware of on this one?
Well, Eric is a TNI expert, so I completely agree with him. So based on my experience, I just want to add a little bit more on that. So I want to emphasize the importance of the data management. Basically, for floating wind project, it will involve many parties, many contractors during the fabrication and the construction stages. So a well-established data management system will be crucial to ensure the information transfer from the design stage into fabrication, installation, and operation stages. So this established data management system is a core part of the floating wind integrity management system. We normally call it a structure integrity management system, a SIM system. So this system will effectively manage the structure risk across the whole life cycle of the floating wind assets.
Okay, really useful. Okay, so look, we've talked about design, we've talked about installation. You just mentioned operation, so let's dig in a bit more into that in terms of the operation phase and what's important. I'm definitely going to Aaron for this one because Eric's had the last two. So Aaron, what can you give me some thoughts about the operation phase?
Sure, thank you, Stu. No worries. So, yeah, I've been mainly focusing on the operation maintenance side of both oil and gas and offshore wind assets in the last 10 years. So from the cost perspective, I think the floating wind can potentially offer a much lower O&M cost than the bottom fixed wind. So for example, I can see the question from raised just before this question. For major inspection and repairs, the floating wind structure can be disconnected from the mooring line and towed back to the harbor. So this will lead to the significant delays the offshore activities comparing to the fixed platforms, fixed offshore wind turbines. So as I mentioned earlier, the SIM system can help to define a fit-for-purpose O&M strategy in order to optimize the scheduled maintenance plan activities, minimize the unscheduled inspections, and in order to reduce the lifetime maintenance cost. Okay. That's from the cost perspective. From the technical perspective, so the floating offshore wind are normally the steel-plated structures with extensive welded connections. So there are two main degradation mechanisms during the operation along the life cycle. So there are the corrosion and fatigue. To prevent and mitigate these two risks, so we need to build up the knowledge of the structures and better understand the structure risk. Again, establish the SIM system can help to achieve this goal.
Got it. Okay. Go on, Eric. I'm sure you've got some views on this as well. What anything to add?
Yeah, a few things to add. So Aaron has been talking about the steel floaters, the steel structures. In terms of O&M, I would like to talk about the concrete type concepts, which bring the advantage of longer design life, and particularly high resistance to the offshore environment with low O&M costs. I'm thinking here about two concrete type concepts that have been exposed to. One of them is currently installed off the coast of Saint-Nazaire, west of France. And I'd be very curious to hear from the operator, but from the floater designer as well, the feedback from an O&M point of view, again with regards to the floater design and resistance to the offshore environment. To come back to your question, Stu, with regards to operations in floating wind, it is important to know from the developer the strategy in terms of major components change out, but as well in terms of access of technicians. Indeed, at the moment on the market, there are various floater concepts and they all offer different dynamic responses. Therefore, they offer different weather accessibility. So this is a factor that have to be taken into account from the start of the project development phase. And we will not insist enough that O&M operators, O&M contractors have their words to say early on in the project development.
Got it. Okay. That's really good insights from both of you. Thank you both very much. And I know that we talked a little bit, we've mentioned some of the projects that are already happening or about to happen, but where in the world, do you think we're most likely to see more floating offshore wind? Aaron, how about you for this one? Yeah.
Well, it's very good question, Stu.
I try.
Yes, it is. I think in general, there are about 3-4 key markets for floating wind in the next decade. So first, for the site locations, it has to have very good wind resources and in a deep water depths. and close to the coast. So in that area, such as Scotland, Norway, Japan, and the west coast of US, like California, etc. And the second market would be the locations near the oil and gas complex platforms, which can be powered by a floating wind farm and in the deep water environment. The third market would be some isolated islands with very high electricity generation cost. Last but not the least, I think, as I mentioned earlier, some relatively shallow water between 46 meters. This area had a very hard rock seabed conditions, or maybe had a very strong current, which are not very suitable for the bottom wind foundations. So there is the opportunity for floating wind in that area as well.
Okay, Aaron, thank you so much. That's really, really good insight. Now then, come on, I've asked you a couple of easy questions. Let's go for a hard one. What do you see, looking ahead, what do you see as the future of floating offshore wind? And I'm going to drop you in it, Eric. This one's for you.
Sure, yeah, thank you. So this is a very interesting but very tricky question. So if I could see the future, Stu, I wouldn't be working today. I would be on the beach drinking margarita. No, seriously, I really see a great future in a floating technology. Floating wind is no more at prototype stage, as we presented earlier on. Floating wind is no more a niche market. It has proven it works. It has also proven it's not a technology for a few privileged companies. It's totally the opposite. It's a technology that is good for both small and large companies, like small developers, large utility companies. It's good for large national markets like Japan, UK, USA. It's good for smaller regional markets, and it attracts as well a lot of companies, utilities, investors, suppliers, but above all the professionals. The excitement in my network around floating wind is really amazing. Floating wind attracts project managers, engineering managers, contract managers, technicians, everybody, finance people. So from that point of view, it's really interesting to see the interest in the floating wind technology. But to add as well, another point, I think floating wind will get sympathy from the stakeholder and from the public as a whole, because floating wind is further ashore, so it has less visual impact, and at the end as well, it has less environmental impact. So with all the things together, I try to see the future, and I can predict that I see a great future in floating wind.
Brilliant. Thank you so much. Now, I can't let Aaron away without asking him the same. So, Aaron, crystal ball time. What's going to happen?
Okay, I have the crystal ball now. So I think, everyone knows climate change is happening. So to achieve the long-term goal of the Paris Climate Action Plan, floating wind development can really not be ignored. So it will play a significant role in the wind power sector. So it's worth noting that last week in the recent ScoreWind leasing round, as Eric mentioned, potentially around half of the planned option sites are suitable for floating wind. So these sites will be fully developed in 2030s. It's not far away. So with government support and the low-cost financing, continued design optimization, as we mentioned, improved the fabrication installation processes, and OEM cost reduction. These factors will make the floating wind a competitive solution for the future of the wind market. So finally, I think the knowledge transfer is also important. The knowledge transferred from the supply chain developed in the oil and gas industry, in the bottom fixed wind industry, will be crucial for the floating wind industrialization. So we believe the floating wind can significantly reduce its cost and achieve the economies of scale, and finally reshape the offshore wind industry in the next decade.
Oh, really good point.
Thank you.
Really good points. Really good points. Okay, so just before we move to wrap up, I thought we've talked a little bit about the future of the industry, but what would be really useful also is if the audience could give us a little bit of feedback about what perhaps we could discuss in the future. So I've just put a poll live now. If everyone clicks poll at the bottom. Eric?
Yeah, just a comment. I see a very interesting question from Satish on the benefit of semi-subs in terms of motion response. But actually,
go for it.
I propose this is a topic we cover more in detail in one of the articles that you are going to put on the poll.
Okay, brilliant. No, we can definitely do that. So I think people should be able to see the poll now. If I make it visible. Oh yeah, we've got some votes coming in for what we could perhaps discuss next. So we'll add that question to the list as well. If everyone could just quickly, if you click poll at the bottom, you'll see there, what would you like us to see discuss next? And we'll have a little look. The votes are coming in. Eric, can you see them coming in live?
Yeah, I see it. It's yeah.
Well, it looks like we might have to do 3 sessions, I think. They're all pretty popular. Here we go. It looks like we've got our work cut out, I think. We might have to do all 3.
Well, we're going to be busy.
It's a pretty even race, this one, isn't it? Carl, I hope you're voting for your favorite as well. Don't think you're getting away with this because we might make you actually do it. So you shouldn't be laughing too much.
I'm not voting.
Okay, so right, I think we'll call that poll time there. So it looks like we got more votes coming in.
Still moving.
Still moving.
We have connected on the session.
And we've got 105 people all the way through. So look, I'll just keep that up there. But I just wanted to say thank you all, everyone, for today. Really big thanks to Eric and Aaron. This is the first time they've done anything like this. So I think they've been absolutely brilliant. I'd like to thank you all for joining us on what has been our first ever session like this. And if you found it useful, please take a look at the Empire Engineering website. We have a whole host. I nearly got through the whole session without tripping up. We have a whole host of interesting articles and opinion pieces for you to take a look at. So thank you very much for letting us know what we should do next. I just also want to add, if you've enjoyed today and you feel that your team would benefit from a more expert deep dive session, as Empire, we run 1-day training courses, and we've moved them from in the office to virtual naturally through the summer. So if you just send an email to contact@empirengineering.co.uk, you'll be able to contact the team directly about there. And finally, last but not least, I feel that it would be very important to just mention that we are, of course, running Foundation X on October the 13th, 2020. This was our conference we ran last year in Bristol, and we'll be running it again this year. And we are potentially looking at virtual options. It just depends on what's the right thing to do once we get a little bit closer to time. So look, that's it for today. I appreciate we've not managed to answer all of the questions that were asked. This session is being recorded. We will put it on the Empire site. We'll also add a blog post to answer some of the questions that have come in that we didn't manage to answer live on the session. And that finally just leaves me to say thank you all so much for joining. And thank you again to Eric and Aaron. And we are done. Thank you very much.
Thank you.
Bye, everyone.
Thank you very much.
Merci beaucoup.